This is our spring test number 11 on measurement. First section tells you to choose the approximate measure. We're not going to use any of the same letter more than once in this case. Number one says an average door height. Best one that goes with an average door height is E 6.5 foot. Baseball diameter is the next one. I actually had to look this one up because there's two answers that are very, very close to each other, both 3 inches and 2.5 inches. And it's actually, it varies slightly, but it's closer to 3 inches in both cases that I found. So G for number 2, which led me to believe that H had to be for number 3, the diameter of a cookie. So EG then H. A hot dog length was a little easier to understand looking at the choices we had. 5 inches was the closest hot dog length, F. Piece of a paper, how wide is a piece of a paper? 8 inches across, B. The average weight of a bag of chips, the only weight measurement that you're given at all is J, 20 ounces. The average pool depth is I, 5 feet. I had to actually go back and do that one based on what was left over. Average TV has a 27-inch screen. An average basketball goal height is 10 foot. And an average doorway width is 2.5 foot. So use all of them once. The next set deals with which measurements to use, and we will use one of them more than once. Centimeters will happen more than once. The volume of a cup is going to be F, milliliters. The distance from New York to Los Angeles has to be kilometers, D. The volume of a bathtub is got to be liters, G. The weight, it says, of this book, we don't have, but weight of a book is I, grams. The thickness of a quarter is millimeters, A. The length of a worm is B, centimeters. The weight of a kitten is J, kilograms, J, kilograms. A tennis court length is C, meters. The weight of a penny is I, grams. Actually, that one shows up twice. And the dog's tail is B, centimeters. So both I and B show up twice. For the next section, we have to use significant digits to solve these 4 problems. When you add 137 to 0.0246, you get a number that says 1.3946. You have to determine how many significant digits you have. In the first number, you have 3, and in the second number, you have 3 because you don't count the 2 zeros. So your answer needs to contain the first 3 numbers, 1, 3, and 9. 4 does not tell you to round up, so your answer with the correct amount of significant digits is 1.39. On number 22, we have 406.2 minus 12.08. So 406.2 minus 12.08. When you subtract those from each other, you get the number 394.12. Just like we would normally subtract, but again, you have to make sure you have the correct amount of significant figures. The first number, as you look at it, all 4 of those numbers are significant because the 0 is between 2 numbers, so that one has 4 significant figures. And as you look at the second number, all 4 of those are also significant because the 0 is between 2 non-zero numbers. So our answer has to have 4 digits for this problem, or 4 significant figures. The first 4 numbers, 394.1. 23 says 13.79 times 112.4060. You get this great big number that looks like this, 1550.07874. Again, we have to determine how many significant figures. This first number has 4 of them. None of them are zero, so that has 4 significant figures. This second number, you count the first 0, but you don't count this second one because it's not between two numbers that are not uh, non-zeros. So you have 1, 2, 3, 4, 5. There are 6 significant figures for that one. Again, you always pick the one that has the smaller amount out of the two to see how many numbers you have in your answer. So our answer has to have the first 4 numbers. 1, 5, 5, 0. That 0 is significant for the reason that it is between two numbers that are not zero. So that would be your number, 1550. Written as in scientific notation would be 1.55 times 10 to the fourth. For this one back here, 3.941 times 10 to the second power. Moving that decimal, just all that was moving that decimal from here to a number to make it between 1 and 10, and from here to a number to make it move it 2 times to make it between 1 and 10. For number 24, you have the number 37.4 divided by 4.307. Again, you get a great big number, 8.68, 353, 8426. We have to determine again how many significant figures. This one has 3 significant figures. All 3 of them are non-zeros. This one has 4 significant figures because you count the 0. It's between 2 non-zeros. So since this one has 3, that's the smaller number. That's the amount we want to use. So the first 3 numbers, 8.68, is your answer written with the correct amount of significant figures. Checking out that 3 after the 8 determines if we need to round it up to 9. It's not 5 or greater, so we leave it just like it is. Same thing with all the other problems with 9. 4 wasn't high enough to make it round. Neither was this 2 high enough to make the 1 round. Next section says convert the following measurements. 12 pounds to ounces. There are 16 ounces in 1 pound. So all you need to do is 12 times 16, and you get 192 ounces. This next one's tough. 640 ounces equals how many gallons? A lot of different conversions going on here. The first one, 16 ounces are in 1 pint. 2 pints are in 1 quart. And 4 quarts are in 1 gallon. So to go from ounces to gallons, you have to do 3 different conversions. So what we need to do, since there are 2 pints, since every 16 ounces is 1 pint, and for every pint, there are 2 pints in every gallon. I'm sorry, in every quart, I can't talk for a second. 2 pints in every quart and 4 quarts in every gallon. You need to multiply 4 times 2 and get 8. So what that tells you is that there are 8 pints in every 1 gallon. 8 pints in every 1 gallon. And if each pint is 16 ounces, that means you need to multiply 8 times 16 to get 128 ounces in every 1 gallon. So if 100, this is the conversion you need to use right here. We had to do 5 conversions to get to it. But for 128 ounces in every 1 gallon, so 640 divided by 128 leaves you with a nice, neat looking 5 gallons. Number 14 says there are, in 14 yards, how many inches? We know that there are 36 inches in every 1 yard. We did that. So multiply 14 times 36, 504 inches. Number 28 says 80 ounces or how many pounds? Again, going back to the first one, 16 ounces in every pound. Divide 80 by 16, and you'll see that that's 5 pounds. 2 miles or how many feet? In 1 mile, there are 5,280 feet. So multiply 2 times 5,280, and you get this great big number, 10,560 feet in 2 miles. 64 pints or how many quarts? There are 2 pints in every 1 quart. So divide 64 by 2, and you get 32 quarts. 31. This is one we didn't look at, tablespoons. So when it shows up tomorrow in the test, it'll be a bonus one, tablespoons. There are 2 tablespoons in every 1 ounce. 2 tablespoons in every 1 ounce. So 30 divided by 2 would be 15 ounces. 37 feet is how many inches? We know that there are 12 inches in every 1 foot. So 37 feet times 12 will be 444 inches. 53 pints are how many cups? We know that there are 2 cups in every 1 pint. So 53 times 2 will give you 106 cups. 34 says 416 ounces is how many pounds? Again, we know 16 ounces is 1 pound. So divide 416 by 16 and you get 26 pounds. 5 miles is how many inches? Now this one's tough. We know that there are 5,280 feet, and feet equals 1 mile, and we know there are 12 inches in 1 foot. So 5,280 times 12 is 63,360. So there are 63,360 inches in every 1 mile. So if there are that many inches in 1 mile, when you multiply that by 5, you get this number, 316,800 inches in 5 miles. And then the last one you had to do, 116 quarts equals how many gallons? We know that there are 4 quarts in every 1 gallon. So divide 116 by 4 and you get 29 gallons. The next part of the study guide asks you to pick the most precise measurement. They don't give you any unit measures. You pick the one that has the most amount of numbers after the decimal, 0.005. 0.0 for that one to the nearest tenth. 4.81, two digits after the decimal. For this next one, you have fractions shown up, 1/2, 1/4, 1/8. You want the one that has the smallest fraction, 1/8. The smallest one is the most precise. And then again, the most digits that come after the decimal, 51.321. Those are your most precise measurements. The last part you had to do was fill in the absolute error. Again, leaving the relative error off. We'll get to that later. 202 miles minus 200. Take the larger one and subtract the smaller one from it. 2 miles is your absolute error for the first one. 50 minus 48 ounces is 2 ounces is your absolute error. And then 5/7 and 6/7. Take the larger 6/7 and subtract 5/7 from it. 1/7 of an inch is your absolute error for that one.